Welcome back, friends. Already in introduction, we discussed three things. One is that to keep object in motion, force is required. Second thing, to keep object or to stop moving object, force is required. And third question, is an external force required to keep a body in motion? These were the three simple questions. These questions, seemingly simple, were answered by few great minds, but it took ages for them to answer these questions. And Aristotle is one of them. In this section, we are going to discuss Aristotle's law and Aristotle's policy. This is 5.2, Aristotle's law. First, let us see what is Aristotle's law. An external force is required to keep body in motion. This is the Aristotle's law. An external force is required to keep a body in motion. And external force is required to keep a body in motion. Aristotle, the great thinker, during 384 BC to 322 BC, tried to give answer to these questions. Aristotle held the view that the force is required to keep the bodies in motion. The view was part of the ideas developed by Aristotle while studying motion of an object moving in the universe. The sole basis of observation is just the terrestrial objects. He came to this conclusion by observing the sky, and after long observations, he formed this view, that is, an external force is required to keep a body in motion. And this is our common experience also. An arrow shot from a bow needs force, and it is given by air behind it. The push given by air behind an arrow keep it moving in forward direction. Another simple example, a child playing with toy car, non-electric toy car, needs to drag it constantly with the help of string. As soon as he releases the string, toy car will come to rest. This is another common experience, or this is observation. It means that whenever we want an object to move, then an external force is required to keep it in motion. This was the law given by Aristotle. This law, any terrestrial object, celestial object is moving, and external forces are required to move them. Left to themselves, eventually they come to rest. This was the view held by the great thinker, and who gave this law, an external force is required to keep a body in motion. But this law was too wrong. Today we all know that this is wrong, and we don't concern we don't keep any concern about this law because it is already discarded. But where Aristotle went wrong and what he did not consider, that is called as Aristotle's policy. Where Aristotle's policy. See that the force which is required to continue toy car in motion is used to overcome frictional force between the tires of the car and the surface on which it is moving. If the frictional force is reduced, the car keep on moving for a longer time, and if the friction between surface and the car tire is removed completely, then car does not require any external force. Similarly, any object which is flying or moving in a liquid, their motion is opposed because of viscous drag. The friction is the force due to solid, but viscous drag or force of friction by liquid and air is called as viscous drag. So these forces, frictions are present everywhere. If we remove this frictional force, then the force is not required to make an object move in uniform motion, and Aristotle failed to consider this frictional force. Later on, this was corrected by the great mind Galileo Galilei in 17th century, and he came with the basic law of inertia. He said that no external force is required to keep an object in uniform motion. This view of Galilei Galilei gave foundation to Newtonian mechanics and which further developed modern science. This is the link. First, the study began with Aristotle, then it was corrected by Galileo Galilei, and then the complete soul of this Newtonian mechanics or the basis of this modern science was developed by Newton, which today we all are enjoying. In this session we discussed Aristotle's law, then we also discussed Aristotle's policy, and basically Aristotle did not consider force of friction. And third thing, now the next person who studied these things in detail, that is Galileo Galilei. That's all. Thank you.